So for today's discussion, we will do some, uh, we will solve some convergence or divergence of series, okay, using limit comparison test and alternating series test, okay? So let us recall kung ano yung sa limit comparison test. So here we have two series with AN and series with BN. So these series are series with positive terms. So AN are all positive and BN are all positive. Then we have these three cases. So sa first case, if the limit of AN over BN equals a constant, a positive constant, okay, then both series AN and the series BN are convergent or both of them are divergent. Okay? So again, limit of AN over BN as n approaches infinity equals a positive constant. Then both series converge or both diverge. Now, if the limit of AN over BN is equal to 0 and the series BN is convergent, okay, then the series AN is also convergent. And the third case is if the limit of AN over BN as n approaches infinity is positive infinity, okay, and the series BN is divergent, then the series AN is also divergent. Okay? So, for me, usually ang ginagamit ko lang sa limit comparison test ay itong first case. Okay? Itong first case. Itong second and third case, bihira ko itong gamitin. Pero of course, sometimes helpful naman itong dalawa na to. Just make sure na hindi nyo mapagpapalit yung limit condition at saka yung convergence or divergence ni BN. Okay? But I guess mahuhulaan nyo na yon. If you are going to use AN over BN, okay? AN over BN, this ratio here. So kapag yung limit ni AN over BN ay nag-exist because it's equal to 0, tapos yung ilalim, convergent, yung ibabaw magiging convergent. So nag-exist na limit, convergent BN. Okay? Now, kapag yung limit ni AN over BN hindi nag-exist, kasi plus infinity, di ba? So, ibig sabihin nun, hindi nag-exist. Okay? So, yung limit, hindi nag-exist, tapos divergent yung conclusion. Meaning, divergent din dapat yung ilalim. Okay? So, medyo madali rin naman tandaan ito. Okay? Pero tulad yan ang sabi ko, ang madalas ko lang ginagamit sa limit comparison test ay itong first item. Okay? So, why? Look at this. If the limit of AN over BN equals C, which is a positive constant, then you can also compute yung limit ni BN over AN. Correct? This is simply the limit of 1 over AN over BN as n approaches infinity, of course, as n approaches infinity here. Then, this limit here, it's just 1 over C. And this C here, since it is positive, it's not equal to 0, 1 over C exists. Okay? So meaning, pwede mong pagpalitin yung pwesto ni AN at ni BN. Okay? Pwedeng AN over BN, pwedeng BN over AN. And both C or 1 over C are positive. And they have the same conclusion or the same convergence or divergence. So sometimes, instead of writing AN over BN, mas okay isulat yung BN over AN. Mas madaling i-simplify yung ratio. Okay? So ipapakita ko mamaya yon. Okay? Pero for items 2 and 3, hindi mo magagawa itong pagpalitin. Siyempre, magpapalit sila ng conclusion. Kapag dito sa case na to, AN over BN equals 0, yung BN over AN equals infinity yon. So, nakakalito na siya. Okay? Similarly, for this, an over bn, nagpupunta sa plus infinity, yung bn over an magpupunta sa 0. So, nakakalito na siya. Unlike for this, ang iisipin mo lang, dapat yung limit positive constant. Kahit ano pa siya, basta positive constant. Okay? Tapos yung conclusion is pareho. Yung convergence or divergence nung dalawang series. Okay? Now, tulad ng sabi sa lecture, kailangan mo ng mga um, parang malaking database na ipagkokomperan si series AN. So meaning dapat marami kang kabisadong BN or the series BN. Okay? But I'll give you some tip. One tip is remember yung mga polynomial functions, okay? Mas mabagal ito kumpara sa mga exponential functions. Okay? So, meaning, mas malaki yung exponential kaysa sa polynomial. Tapos, yung polynomial, mas malaki naman siya kumpara sa logarithms. Okay? So, yung logarithms, sa sequence na ito ng type of functions, yung logarithm, mabagal yan. Tapos, yung polynomial, mas mabilis sa logarithm, pero pinakamabilis ay yung exponential. Okay? Comparing these three. Okay? So, mamaya makikita nyo kung bakit helpful itong sequence na to. Log, poly, and then exponential. So, let us consider this series. So, we want to determine whether this series is convergent or divergent. So, we have the series 1 over 3 to the n minus n cubed. Okay? So, kung iisipin nyo yung magiging bn natin, of course, automatic, ito na lang gamitin nating bn, ano? Ay, an, ano? Yung magiging bn nyo, it will be 1 over something. So, pipiliin mo lang yung either 3 to the n or yung n cube. Okay? Tapos, pipiliin mo yung mas mabilis sa kanilang dalawa. At tulad ng sabi ko, mas mabilis yung exponentials compared sa mga polynomials. Yung candidate na bn mo, okay, will be 1 over 3 to the n. So here, your n runs from 1 up to infinity. But this is just your geometric series 1/3, okay, to the n, and from 1 up to plus infinity. And what? This is convergent. Okay, this series is convergent with because this is a geometric series. So geometric series with r equals 1/3. So kung kuhain natin absolute value, 1/3 less than 1. Okay, so convergent siya. Okay? This kind of reasoning, ganitong line na to, ina-accept ko na to. Okay? So kung ganito yung magiging solution nyo, ina-accept ko tong step na ito. Okay? So, what do we need to do now? So either you look at this, you now compute for the limit of, so ito no, isulat natin na ito yung ating bn. Okay? Ito yung magiging bn natin. And of course, ito yung an natin. So we want to compute now the limit of, so limit of an over bn. Okay? As n approaches infinity. But this one is what? Limit of, as n approaches infinity, yung an natin, okay? Yung an natin, that's 1 over 3 to the n minus n cube. Yung bn natin, that's 1 over 3 to the n. Pero since nasa denominator siya, kunin na natin yung reciprocal. So, mumultiply na lang natin siya sa 3 to the n. And notice what will happen dito. Okay? We have now the limit 3 to the n over 3 to the n minus n cubed as n approaches infinity. Okay? Now, look at this. You have 3 to the n over 3 to the n minus n cubed. And you can work on this using all the techniques that you know from Math 21. Okay? Pwede kayong mag-multiply and divide by 1 over 3 to the n, etc., etc. Okay? But remember, just earlier, instead of computing an over bn, mas madali minsan computein yung limit ng bn over an. So ipapakita ko sa inyo kung paano magiging handy yon. Okay? So instead, i-compute ko yung limit ng bn over an as n approaches infinity. Okay? And if you do this, of course, yung bn nyo mapupunta yan sa numerator, which means yung bn, it's just 1 over 3 to the n. Tapos, nasa denominator si an, so kukunin mo yung reciprocal nito. So you multiply this by the reciprocal of 1 over 3 to the n minus n cubed, but that's just 3 to the n minus n cubed. And notice, mas madali itong i-simplify at kuhaan ng limit. Okay? So if you distribute this is just what? 1 minus n cubed over 3 to the n. Okay? And tulad ng sabi ko kanina, since polynomial ito and cube, ito ay exponential, mas mabilis si exponential. Okay? If you pass to the limit as n approaches infinity, itong guy na to, mapupunta lang sa 0. Okay? Mapupunta lang to sa 0. So alam mo may limit ka, which is equal to 1. Okay? But let us compute this. Let us compute the actual limit. What you're going to do here is to apply a L'Hopital's rule. For this guy here, L'Hopital's rule 3 times. Okay? In fact, dito, ganun lang rin gagawin nyo. So, pwede nyo i-simplify or pwede nyo i-apply L'Hopital's rule 3 times. Okay? Kuha nyo. So, in any case, I will accept the fact that this guy will go to 0 because exponential functions are much, much, much faster than the polynomial. Okay? Which means in here, this is just equal to 1. Okay? So you can say that since exponentials are faster than goes to, so exponentials go to infinity. So go to infinity much faster, okay, much faster than polynomials. Okay? I will accept this. I will accept this reasoning. Okay? So, may limit tayo for bn over an, and the limit of an over bn is just the reciprocal of this, and it's still 1. Okay? And since this guy here is convergent, we conclude that the original series, so the series n from 1 up to infinity, okay, and from 1 up to infinity of 1 over 3 to the n minus n cubed, this is also convergent. Okay? Question? All right. So let's move to our next example here. So determine whether the series is convergent or divergent. So in here you have series n minus 2 over n times 5 to the n, okay? Where your n runs from 1 up to negative infinity. Now, observe the terms here, okay? The terms here are not always positive because when n equals 1, negative, this guy here, it's negative. When n equals 2, this is 0. But when n equals 3 and further, this is positive. So you can always start with n equals 3 and then just add n equals 1 later. Okay? N equals 1 later. So let's just do that. So this is this series. You can write this as when n equals 1, you have negative 1 over 5. Correct? 1 minus 2, that's negative 1. This is 1. 5 to the 1, that's 5. And then plus, when n equals 2, this is 0. And then you just add here the sum from n equals 3 to plus infinity of n minus 2 over n times 5 to the n. So this guy here, positive terms na. So just work on this series and then you add this, you know if it is convergent or divergent. Okay? And what do we do? So, well, you can have 1 over n. Okay? You can also have 1 over 5 to the n. Okay? Notice if you separated the two guys here, n minus 2 and then in here, one of the two series there will be automatically convergent. Okay? For example, if we further separate them, you will have something like this. So you have negative 1 over 5 plus the sum, and from 3 up to infinity of what? 1 over 5 to the n. Okay, so that's for your n over n times 5 to the n. So the n will cancel. And then minus the sum of 2 over n 5 to the n. Here n runs from 3 to plus infinity. And you know that this guy here, it's convergent because this is just geometric with 1 over 5 as the ratio. For this guy here, we can what? We can use limit comparison test to show that this one is convergent or divergent. Actually, this guy here is convergent. Okay? So for this, you can say this is convergent. This is convergent because it's a geometric series. Since it is a geometric series, it is a geometric series, geometric series with r equals 1 over 5, which is less than 1 again. Okay? And then for the other guy, hanapan natin ng Bn. So either 1 over n or 1 over 5 to the n or 1 over n 5 to the n. Pero yung 1 over n 5 to the n, ito na yun eh. Diba? Na-multiply lang sa 2. So parang ganun pa rin. I-explain mo pa rin kung bakit siya convergent. So yung 1 over n naman, yung n, it's a polynomial, mabagal yan. So gamitin natin yung 5 to the n. Okay? Gamitin natin yung 5 to the n. So meaning, for this guy here, we will consider 1 over 5 to the n, okay? And from 3 to plus infinity. And again, this guy here, it's convergent. Okay? Because of this reasoning. Same reasoning as in this guy. Okay? And then, ito yung kunin natin AN, ito yung kunin natin BN. So let me just write that. Let's use this as our BN, and then let's use this as our AN. Okay? So in here, pwede mo nang gamitin yung AN over BN. So we now look at the limit of AN over BN, and okay, and approaches infinity. So ano mangyayari dito? We have, oops, sorry. So in here we have yung AN natin, it's 2 over n 5 to the n as n approaches infinity here. And then yung Bn natin, it's 1 over 5 to the n. Kunin natin yung reciprocal, so this is just multiplied to 5 to the n. And notice, of course, this 5 to the n will cancel the 5 to the n at the denominator. And therefore, you'll just get 2 over n. Okay? And the limit of 2 over n as n approaches infinity, this is equal to 0. Okay? So this is case 2. We have the limit of an over bn, that's equal to 0. And the lower, or the denominator, okay, the denominator is convergent. We conclude that the numerator, the an, the series with an, is also convergent. Okay? So since series 1 over 5 to the n is convergent, so is the series 2 over n 5 to the n is also convergent. And therefore, itong original series natin ay convergent. So therefore, or thus, the series n minus 2 over n 5 to the n from 1 up to infinity is convergent. Okay? Question? Let's look at the next problem here. So we have the series ln1 over square root of n e to the n. Okay? Yung n equals 1, pwede na natin tanggalin dito because ln of 1 it's equal to 0. So basically, nag-i-start lang to sa n equals 2. Okay? So this guy here, it's the same as the series starting from 2 plus infinity. So ln n over square root of n e to the n. Okay? Now, how do we do this? So we have some logarithmic in the numerator, okay? And then we have the square root on the denominator, square root of n, and then we have e to the n. So comparing dito sa tatlo na to, ang pinakamabilis ay yung e to the n. Okay? Yung pinakamabilis dito ay yung e to the n. So which means this is our an. We look at we use this as our an, and then we consider now the series 1 over e to the n as n runs from 2 to plus infinity. Okay? Or this is just what? Sum 1 over e, quantity to the n running from 2 to plus infinity. And again, this is a geometric series with r equals 1 over e. And 1 over e, it's less than 1. So this guy here is convergent. Okay? Convergent since it is a geometric series. It is a geometric series with r equals, or absolute value of r equals 1 over e, which is less than 1. Okay? 1 over e, which is less than 1. So, convergent. So, pwede natin itong i-prove na convergent. Okay? Kung yung limit, constant. Okay? Or, kung ito yung iti-take nating bn at kukunin natin yung limit na an over bn, kapag yung limit ay equal to 0, then this is still convergent. Okay? So, ang iiwasan natin is yung limit na an over bn to be plus infinity. Wala tayong magiging conclusion doon. Okay? But anyway, so again, this is our bn. So, we are getting the limit an over bn n approaches infinity. an it's ln n divided by square root of n e to the n, and from approaches infinity. And then bn, it's 1 over e to the n, so reciprocal, this is just e to the n. Okay? And then, magka-cancel si e to the n, so that we'll be left with the limit, okay? We'll be left with the limit of ln n divided by square root of n goes to plus infinity. Okay? And then, replace lang natin na isipin natin na functions sila, na continuous functions sila. So, I'll replace the variable with x so that I will have here ln of x divided by square root of x. And as x approaches infinity, ln of x goes to infinity, square root of x also goes to infinity. So this is of type infinity over infinity. So we use L'Hopital's rule here. And we will get limit as x approaches infinity, derivative of ln of x, that's 1 over x, derivative ng square root of x, that's 1 over 2 square root of x. Or if we simplify this, meron tayong limit as x approaches infinity of 2 over square root of x. Correct? So, isimplify lang natin to. Magkakaroon ka ng square root of x over x. Okay? And square root of x over x, that's 1 over square root of x. So, numerator, it's fixed constant equal to 2. Denominator goes larger and larger. Okay? So, this guy here will go to 0. Okay? So, limit an over bn, it's equal to 0. Yung series containing the denominator, it's convergent. Then we conclude that this guy here is convergent. Okay? So, the series ln of n over square root of n e to the n, and from sulat na natin 1 up to plus infinity, this guy here is convergent. Okay? Question? For next problem here, you have determine whether the series is convergent or divergent. I think ginawa nyo na to. No? Ginawa nyo na to, series ln n over n. Okay? So, skip na lang natin ito. Nasa discussion video din ito. But what you're going to do is, so kung ito yung an nyo, okay? Kung ito yung an nyo, try nyo i-compare, okay? Try nyo i-compare with the series, with the harmonic series. Compare with the harmonic series 1 over n. So n from 1 up to infinity. So harmonic series, this is divergent. Okay? This is divergent. So kung divergent yung pinagko-comparean nyo, either yung limit ni an over bn, it's a positive constant or plus infinity. Okay? So positive constant or plus infinity para magkaroon ka ng conclusion dito. Okay? But if you do this, actually, what you will get is the limit of an over bn equals plus infinity. And therefore, this guy here is divergent. Okay? So, I'll skip the solution kasi nakita nyo na yon dun sa kabila. Dun sa discussion video na pinrovide ng department. Okay? So, let's go to our next example. So, medyo gawin natin lagyan natin ng konting hirap. Okay? So, prove that if an is greater than or equal to 0 and the sum an converges, then the sum an squared also converges. Okay? So you can do this in several ways. Well, I can think of two ways immediately. One is with the use of comparison test. The other one, gagamitan natin ng limit comparison test. Correct? Since nasa limit comparison test tayo, yun yung gagamitin natin. Okay? So, how is that? How is that? Okay. Ito yung gusto nating i-prove. Ito yung gusto nating i-prove na convergent. So, ito yung gawin natin. So, basically, gawin natin tong Cn. Okay? Sabihin natin ito yung Cn natin. Tapos, ito yung gagawin nating Bn. Okay? Instead of an, syempre kasi ginagamit na natin yung an dito. Ginagamit na natin yung an dito. So, gawin ko na lang Cn tapos Bn. Okay? So, ito yung gusto nating i-prove. Okay? Gagamitin natin, ipang-compare natin si series ni an. And we call that the Bn for the moment. So that what we're going to do is you will get the limit. So proof. So one has the limit of Cn over Bn, okay, as n approaches infinity. This is equal to the limit as n approaches infinity. Yung Cn, ito yung gusto nating i-prove kung convergent or divergent. That's your an squared. An squared over si Bn, dito natin siya i-compare. That's your an. This is an. Of course, an squared divided by an, that's just an. Correct? Correct? This is equal to the limit of an as n approaches plus infinity. Okay? Now, I think kapag ginamit natin yung limit comparison test, since magkakaroon tayo ng denominator na an, dapat walang equal sa 0, no? So, assume na lang natin na hindi talaga siya equal sa 0. Okay? Hindi talaga equal sa 0. So, tanggalin natin yung condition na yon. Okay? Tanggalin natin yung condition na lang na to. Kasi syempre kung 0 siya, hindi natin magagawa itong part na to. Okay? So anyway, anong limit nito? Limit of an as n approaches infinity. Any guess? Remember kung paano nakuha yung divergence test? Yung divergence test, it's a contrapositive of a theorem. Okay? Yung contrapositive ng theorem. Yung divergence test, sinasabi, if the limit is not equal to 0, then the series is divergent. Yung contrapositive nun, yung actual theorem na pinagamitan nun is, if the series is convergent, then the limit of the terms must be equal to 0. This is equal to 0 since, okay, one has this since we assume that the series AN is convergent. Okay? Correct? Ngayon, limit ay equal sa 0 tapos yung Bn mo, which is this guy here, convergent. So yung Cn mo must be convergent. Diba? So, by LCT, let's just write it as LCT, limit comparison test, the series Cn, okay? And this series Cn, this is just your series An squared, is also convergent. And that's the end of the proof. Okay? So, two sentences. First sentence is this, and then second sentence is this. Okay? So, question sa paggamit ng limit comparison test. So, I hope yung tips ko na binigay, yung tips na binigay ko sa first slide ay nakatulong. So, polynomial, mas mabagal yon kumpara sa exponential, pero mas mabilis siya kumpara sa logarithmic. So, alam nyo yung PPDin nyo. Okay? So, there's a question. Paano po naging limit? Paano po naging 0 yung limit ni AN? This is the theorem that we use. So, the theorem, if the series AN is convergent, okay, convergent, then the limit of the terms must be equal to 0. Limit is equal to 0. Ito yung theorem na pinanggalingan ng divergence test. So, ito yung ginamit natin. Ang assumption, nagko-converge yung limit yung series na AN. So, yung limit ni AN must be equal to 0. Okay? Okay. Now, proceed tayo sa mga examples kung saan gagamitin naman yung alternating series test. So, recall lang natin. Suppose the alternating series, at alam natin yung alternating series, ganito yung form. Summation, negative 1 to the n, bn, or sometimes yung exponent instead of n minus 1. Okay? So, whatever. Basta, ang point is, you have this form, tapos yung mga bn mo, positive. Okay? So, alternating series yon. So, suppose we have this alternating series, and this alternating series satisfies the following. Bn plus 1 less than or equal to Bn for all n greater than or equal to k for some positive integer k. Ang sinasabi lang nito is that your Bn is ultimately decreasing. Okay? Ultimately decreasing. Okay? And then, the second condition is the limit of Bn equals 0. Then, our conclusion is that the series, itong alternating series natin ay convergent. Okay? So, gamitin lang natin ang mga ang alternating series test sa mga next examples natin. So, we expect dapat alternating series yung mga series natin. Okay? So, when you have that, check the two conditions. Kung both satisfied, series is convergent. If at least one of them, okay, kung ito o kaya naman ito ay hindi na-satisfy, gagamitin natin ang ibang test. Particularly, gagamitin natin ay yung divergence test. Okay? So, first example, we have here series negative 1 raised to n of n over 9 to the n. Okay? So, of course, we have here n. So, you have here n over 9 to the n over 9 to the n, sequence of positive, okay, positive integers, or sequence of positive numbers, sequence of positive numbers, positive numbers. So Bn are all positive. Okay. So let us look at, so ito, papangalanan natin tong Bn, ano? So let us consider decreasing ba? We can just use yung Bn plus 1 minus Bn. We want to show that this is negative. Okay? So, this is what we want to show. We want to show that this is less than or equal to 0. Kasi, kung less than or equal to 0, it means, lipat mo si Bn sa kabilang side, you have Bn plus 1 less than or equal to Bn. So, yun yung decreasing part or ultimately decreasing part. Okay? Pero, let's plug in. N plus 1, you will have n plus 1 divided by 9 to the n plus 1. And then minus, you have 9 or n over 9 to the n. And then just combine this. What you will get is you have n plus 1 minus 9n divided by, okay, 9 raised to n plus 1. Okay? So, pinagsama mo lang sila sa isang fraction. You multiply 9 sa denominator, magiging 9 raised to n plus 1 siya. So, syempre, dapat i-multiply mo yung numerator sa 9 din. But if you simplified this, what you will get is 1 minus 8n divided by 9 raised to n plus 1. And this is always negative for n greater than or equal to 1. When n equals 1, you have 1 minus 8 in the numerator. It's a negative number. Okay? So, for all n greater than or equal to 1, negative na ito. So, this means that, so, your sequence Bn is decreasing. Okay? Next step, you just need to find the limit of Bn as n approaches infinity. So, this is just the limit of what? N over 9 to the n as n approaches infinity. And again, you can argue that n polynomial sa numerator, exponential sa denominator, magiging 0 lang ito. Mas mabilis yung exponential sa polynomial. Okay? Or you can just use L'Hopital's rule. Okay? So, hindi ko na i-formalize. Okay? Hindi ko na i-formalize. Dito ko na kagad i-apply yung L'Hopital's rule. Okay? Pero for formality, kailangan mong palitan na x or x ito, no? Kasi continuous function yung gusto mo dapat para ma-apply mo yung L'Hopital's rule. So, hindi ko na i-formalize yon. Apply kaagad natin si L'Hopital's rule. Okay? So, derivative of n, it's just 1. Derivative of 9 to the n, it's 9 to the n ln of 9. Okay? So as n approaches infinity, this is equal to 0. Therefore, by AST, alternating series test, okay, the series -1 to the n over 9 to the n is convergent. Okay? Question? Okay? Let's look at our next example. You have sine n pi over 2 over n factorial. Okay? So question is this alternating series? Look at this. You have sine n pi over 2. When n equals 1, you have sine pi over 2. That's positive 1. When n equals 2, you have, what is that? Sine of 2 pi over 2. So that's sine pi. That's equal to 0. Okay? And then when n equals 3, you have sine of n pi over, so you have sine of 3 pi over 2. That's negative 1. So basically, hindi siya nag-alternate. Yun ang mangyayari. Hindi siya nag-alternate. So negative and then 0. Positive and then 0 and then negative and then 0 and then positive and then 0. So officially, hindi siya, meron mga nawawalang terms. Yun ang gustong mangyari. Okay? So if you look at this, magiging ano siya, 1 over 1 factorial minus 1 over 3 factorial plus 1 over 5 factorial minus 1 over 7 factorial plus etc. So yung mga even integers nawawala. Kasi even eh. Magiging 2 pi over 2, so sine pi, that's 0. 4 pi over 2, sine 2 pi, that's also 0. So nawawala yung mga even integers. Ang nakikita mo lang is yung mga odd integers. Which means, we have this, we can transform this into the sum. From n equals 1 up to plus infinity, negative 1, positive siya, no? Nag-start. Pero n equals 1. So gawin natin n minus 1 dito as exponent. And then for the denominator, how do you write this? You can write this as 2n minus 1 factorial. Correct? 2n minus 1 factorial. So when n equals 1, you have 2 minus 1, that's 1. So 1 factorial. When n equals 2, you have 2 times 2, that's 4. Minus 1, that's 3. 3 factorial. When n equals 3, 3 times 2, that's 6. Minus 1, that's 5. So 5 factorial, etc. So this guy here, you can transform it into an alternating series. Kailangan mo lang i-analyze. Okay? Question. In which case, our Bn, this is equal to 1 over 2n minus 1 factorial. Okay? Okay? Now, yung condition na ultimately decreasing. So, this is what we want. This is what we want. Bn plus 1 less than or equal to Bn. Okay? Ito yung gusto natin mangyari. Pero this guy here, it's equivalent to the condition Bn plus 1 over Bn less than or equal to 1. Correct? So, ang gagamitin natin, itong condition na to, para mapakita natin na eventually decreasing itong mga Bn natin. Okay? Eventually decreasing yung mga Bn natin. So, thus, we have Bn plus 1 divided by Bn. This is equal to, yung Bn plus 1, we have 1 over 2 times n plus 1 minus 1 factorial. Gawin ko na lang, no? Kunin ko yung reciprocal ni Bn para hindi masikip dito sa part na to. So, meron tayong 1 over 2 times n plus 1 minus 1 factorial times yung reciprocal ni Bn, it's just your 2n minus 1 factorial. Okay? Then let's just simplify this. In the numerator, you have 2n minus 1 factorial. So denominator, you have 2n plus 2 minus 1. Okay? 2 times 1, that's 2, and then minus 1. So magiging siyang 2n plus 1 factorial. Okay? Tapos, sulat lang natin, definition of factorial. Sa numerator, isulat pa rin natin siya as 2n minus 1 factorial. Yung 2n plus 1 factorial, it's just 2n plus 1 times 2n times 2n minus 1. And then, we put the factorial here. Correct? And of course, makikita nyo, magka-cancel si 2n minus 1 factorial. So, may iwan lang sa atin is 1 over 2n plus 1 times 2n. And definitely, this is less than 1. Okay? For n greater than or equal to 1. When n equals 1, you have 2 plus 1, that's 3, times 2, that's 6. So 1 over 6, it's less than 1. Siyempre, kung pinapalaki mo pa lalo yung n, ano mangyayari? Mas lalong liliit ito na liliit. So less than 1 pa din siya. So ano ibig sabihin nito? Therefore, Bn is decreasing. So that's the first part. Second part, gusto natin makita yung limit equal to 0. Okay? So, second part, para ma-explain nyo na maigi, you know, 1 over 2n minus 1 factorial. This is greater than 0 always. Okay? But this is what? So, isulat mo yung 2n plus 1 factorial. 1 over 2n, 2n minus 1 factorial. So, 1 over 2n minus 1 times 1 over 2n minus 2 times times 1 over 2 times 1 over 1. Okay? Pero itong mga to, ito, it's less than 1. Lahat ng nasa gilid na to, or sa factors na nandito, everything is less than 1. Which means that this whole guy here, it's less than 1 over 2n minus 1. So to find the limit, as n approaches infinity, you use squeeze theorem. This guy, limit goes to 0. Of course, it's just 0. This guy, 1 over 2n minus 1, limit as n approaches infinity equals 0. So, ito, mapupunta lang rin sa 0. Okay? So, since limit of 1 over 2n minus 1 as n approaches infinity, this is equal to 0 by squeeze theorem. By squeeze theorem, yung limit of 1 over 2n minus 1 factorial, this is also equal to 0. Therefore, you conclude that this guy here is convergent. So this guy here is convergent, and therefore, this guy here is convergent. Okay? So, series sine n pi over 2 divided by n factorial, and from 1 up to infinity is convergent. So, I don't have enough space here. Sulat nyo na lang, ha? Convergent. Okay? So, that will be, paano, question here, paano naging less than 1 yung 1 over 2n minus 2? 2n minus 2, when n equals, look, when n, when n equals, well, think of this, yung 2n minus 1 factorial, di ba yung n factorial, this is n times n minus 1 times n minus 2 times that. Tama ba yun? And therefore, 1 over n factorial, this is 1 over n times n minus 1 times n minus 2 times 2 times 1. So, times 2 times 1. Siyempre, ito, malalaki to sa 1 eh. Si n minus 1, mas malaki yan kay 1. Si n minus 2, mas malaki yan kay 1. So, yung mga reciprocal nila, mas maliit na kay 1. Tama ba? For sufficiently large n, 2n minus 2, it's greater than 1. So, 1 over something greater than 1 will be less than 1. Tama? Naintindihan ba yan? Yung 2n minus 2, it's something greater than 1. So, yung 1 over 2n minus 2 will be less than 1. Okay? So, I hope you got that. Well, yung 1 over 2n minus 1, that's a good question. 1 over 2n minus 1, it's also less than 1. Okay? It's also less than 1. Pero, syempre, gusto kong gamitin yung squeeze theorem. So, I need something na magpupunta sa 0. Kaya, iwan ko na lang si 1 over 2n minus 1 dyan. Sure tayo, ito mas maliit kay 1. So, parang itong guy na to, mas malaki sa lahat na nandito. Kasi itong guy na to, minultiply mo something less than 1, liliit siya. Tapos minultiply mo ulit sa something maliit sa 1, liliit ulit siya. So ito, mas maliit to kumpara kung siya lang mismo, 1 over 2n minus 1. Okay? Now, there's a question. Paano nagamit yung squeeze theorem? Ito magpupunta sa 0, oh. Tapos ito, 0 naman to eh. So yung limit ng 0, it's always 0. So wala tayong choice. Ito, mapupunta to sa 0 rin. Yung nasa gitna. Tama? Okay? So, nagets kung paano gamitin yung squeeze theorem? Okay, so Move lang tayo tapos kung, hindi pa rin or medyo nalalabuan pa rin, usap tayo after ng discussion. So ito yung last example, okay? So nakita niyo na kanina na divergent ito, okay? Divergent ito without the negative 1 to the n. Pero mapo-prove nyo na kapag nilagay nyo na yan si negative 1 to the n, magiging convergent siya. So try nyong isolve ito. Okay? Try nyong isolve ito on your own. And then what if pagbalik na rin natin siya? Instead of ln n over n, you have n over ln of n. Ito naman, magiging divergent ito. Okay? So again, for this, you can still use AST. Okay? Alternating series test. Dito, hindi mo na magagamit yung alternating series test. Kasi mag-fail yung isa sa mga conditions. Which means, magagamit mo yung divergence test dito. Okay? Magagamit mo yung divergence test dito. Okay?